Hello, my name is Michaela Grupp, and I'm here to tell you about the phases in a renewable fuels project and some of the important considerations you need to make to ensure the success of your project. I've chosen to split up a renewable fuels project into 3 phases before you reach normal operation, and I'll go more into detail with each phase in the next minutes. But first, the overview. The first phase is the scope and design. The next phase is construction and commissioning, and the final phase is the startup of the unit, and then you reach the operation mode. The scope and design phase consists of 3 phases. First, there's the project development phase, then there's the basic engineering, and this is followed by detailed engineering. It is important to remember that each of these phases ends with a decision point to move ahead or to close the project. The first step is the project development phase, which entails such things as deciding on the products you would like to produce. Do you want renewable diesel, renewable jet fuel, renewable naphtha, or a mix? The feedstocks you have accessible are important, the capacity of your plant, and an overview of the assets and utilities that can be part of the projects. For example, if you have a pre-treatment plant already, it's highly likely that you can use it as a pre-treatment plant for the Hydroflex unit. It is a good idea to get in touch with us as soon as you start thinking about scoping the project, because we have extensive experience in process layout, knowledge on the available feedstocks and the future feedstocks, because you would like to be able to process them as well. And we can also help identifying which assets can be reused or repurposed. A part of the project development phase can be a feasibility study phase, where you engage a licensor, us, to carry out a feasibility study that you can use as input for your business case. At the end of the project development phase, you should have chosen your design feedstock, have decided upon capacity, and know your available utilities, and you should have chosen a licensor. The next phase is the basic engineering phase, where we will carry out the engineering of the Hydroflex unit according to your design basis and provide you with a design package that will enable you to get an even better estimation of the total installed cost, also called the TIC. The basic engineering phase is followed by a detailed engineering phase. One might wonder what the difference between basic and detailed engineering is. Allow me to use a much more simple but very relatable example. If you buy a plot of land and you want to build a house, you will start out by talking to an architect. You will discuss how many rooms you want, if it should be a 1 or 2 story house, if there should be a garage, etc. The architect will then draw up a floor plan, and during that phase, the overall house will be designed. After the architect is done, you hire a contractor to actually build the house, and the contractor will then discuss in detail with you what colors should be painted on the walls, how tall should your kitchen table be, and so on. What we do is similar to the architect. And do keep in mind that this example is highly simplified. The detailed engineering can be carried out by an EPC, an engineering, procurement and construction company, or you can choose to proceed with the detailed engineering alone. At Topsøe, we work with many EPCs all over the world, and we will also stand by during this phase and participate in selected meetings. At the end of the detailed engineering phase, an even more precise estimate of the TIC of the project is given, and the question is now if you proceed to the procurement and construction phase, which is next. The procurement and construction phase is exactly that. The detailed engineering provides input to all of the equipment that you need, and the EPC company is specialized in handling this. The timing of the procurement is important, as there can be long lead items with delivery times of up to 2 years, but these are typically identified during the engineering phase and ordered ahead of time. Next step is the commissioning phase, where everything is checked and it is made sure that the plant is ready for startup. Hardware, in this case Haldor Topsøe reactor internals, will be installed in the reactors. The reactor internals ensure that there's the right mix of gas and liquids and also separate the catalyst beds. The Haldor Topsøe team will be present for installation of the reactor internals to provide advisory services and ensure that the reactor internals are installed correctly. The reactor internals installation is followed by commissioning of the plant, which typically takes place without catalyst in the reactors. After the unit has been checked thoroughly, the catalyst will be loaded into the reactors, again with Topsøe present. Now we get to the phase that is the goal all the way from the beginning of the project. The internals are installed, the catalyst is loaded, and the plant is ready for startup. First, the hydroprocessing catalysts need to be activated, and this is done with the Topsøe team present at your site. After the activation of the catalyst, the startup of the plant takes place, of course also with the Topsøe team present to be able to offer advisory services and thereby ensure optimal performance of your plant. The next phase is the performance guarantee test run. The performance guarantee test run is commencing when stable operation of the unit is achieved. The goal of the performance guarantee test run is to demonstrate that the unit meets the guarantees given by Topsøe. After the performance guarantee test run, the plant continues to run in normal operation, and Topsøe will be available to evaluate the unit performance, the catalyst lifetime expectancy, and discuss optimization of the plant and new catalyst loadings. We're only a phone call away. I hope this gave you an insight into the project phases, and we look forward to discussing your project with you. Thank you.